Today we're going to work on the very last section dealing with matrices and systems of equations. And in order to do that, we need to talk about some important matrix concepts. The first would be the identity matrix. Essentially, an identity matrix is the same thing as multiplying by 1. So just like you multiply some number times 1, you get that same number. You multiply a matrix by the identity matrix, and you get that same matrix. Identity matrices have a main diagonal, that's 1. Everything else is 0. So if I had one that was, say, I sub 3, it would be a 3 by 3 matrix. The main diagonal would be 1. The rest of the elements would be 0. A multiplicative inverse means the number you multiply by something to get 1. So, for example, any value a, the multiplicative inverse is 1 over a, so that if you multiply a times 1 over a, you get 1. That can be written as a to the negative 1 power. The way we say that is the inverse of a. In the same way, if we've got some matrix A, and it's n by n, when we say n by n, that means it is a square matrix. Then the multiplicative inverse would satisfy the rule that matrix times its inverse equals 1, and also the inverse times the original is also equal to 1. Remember that we talked about the fact that matrix multiplication is not commutative. With inverse matrices, it has to be. Pay attention to the fact that the inverse of matrix A is not the same as 1 over A. You actually can't say 1 over matrix A because 1 is a number, and matrix A is a full matrix. So really you can't do that. So let's take a look at some inverse matrices. First thing we will look at is matrix B, and we want to show that a 3 by 3 identity matrix times B will be the same as B. So we go into our matrix function, and we will edit matrix A to be a 3 by 3, and we'll make it an identity matrix. Then we'll go back in and we'll edit matrix B, which is another 3 by 3. And when we show the matrix multiplication, we say matrix A times matrix B, and sure enough, we've got the exact same matrix. The next one asks us to calculate the inverse of B. So we'll go to matrix B here. It's another 3 by 3, and I'm just going to type right over it. And when I want the inverse of this matrix, I go into matrix, I have matrix B here, and I push this button here, x to the negative 1 power. There's my inverse. Now, these are decimals. I can frac this. Not second. Math, the first option is frac, and now it gives us that same matrix with fractions. So I could write that in, that the inverse of B Finally, we're given another matrix, and we're asked to calculate the inverse of that. So this would be matrix A. So I will edit matrix A, enter in my values, and I calculate the inverse. So matrix A inverse, this gives us an error. When you get this error, there is no inverse. So we can say the inverse does not exist. So really what we want to be able to do is use inverse matrices to solve systems of equations. So imagine you've got this system of equations shown here. What we are actually able to do because of matrix multiplication is we're able to say that this matrix with the coefficients times this matrix xy will be equal to a matrix with the constants. Now, if you remember matrix multiplication, and I know it was kind of tricky, we said A times X plus B times Y was equal to C, which is what's written right up here. And then we would do it again. D times X plus E times Y is equal to F. And that's written right here. So what we can do is we can rename these matrices so that the matrix with all of the coefficients would be matrix A. The matrix with the variables in it would be matrix X. And the matrix with the constants in it would be matrix B. What we want to do when we're solving a system of equations is find the values of X and Y, which means we want a solution to matrix X. Well, if you think about how we solved equations, essentially when you divide by A or multiply by 1 over A, what we're really doing is we're multiplying by the inverse of A on both sides times B. This is what we are going to do in order to solve a system of equations using inverse matrices. So let's take a look at our first system of equations. We'll set up matrix A, and that will equal the coefficients, 5, 2, 2, 3. Matrix X is always the variables, and then matrix B will be the constants. So anytime that you are solving a system of equations using inverse matrices, I want to see this. Then what you'll do is tell me that matrix X is equal to the inverse of A times B, and we'll put that into our calculators. So matrix A is a 2 by 2, and matrix B is a 2 by 1. Oops, this would be -1, and this would be 15. And what I want is the inverse of matrix A times matrix B. And so my matrix X is equal to -3, 7. My coordinate solution is -3, 7. That means that X is -3, Y is 7. This works exactly the same way with a 3 by 3 matrix. So we have matrix A. -4, 2. Do notice that there are z's going on here, but this equation doesn't have a z, so we have to input a 0 for z. 1, -1, 2. And then on this last equation, there's no x, so we have to put a 0 for x. And because there are 3 variables, we need to put x, y, and z. So matrix X is still equal to the inverse of A times B. So let's get these put into the calculator. A is a 3 by 3. and matrix B is a 3 by 1. Not a 3 by 12, sorry. Let me go back up to that. That's a 3 by 1. There we go. The first value is 12. And now I want the inverse of A times B. And I get the solution. So x is equal to -3, 0, 5, or we could set this as the coordinates -3, 0, 5.